Look at the moon tonight. It appears calm, constant, almost eternal. It has followed humanity through every age. It illuminated the first human journeys, guided ancient sailors across dark oceans, inspired calendars, religions, stories, and dreams. It watched civilizations rise and disappear. Yet while the moon appears to remain perfectly still, it is leaving us. Right now, at this very moment, the distance between Earth and the moon is slowly increasing, not by thousands of kilometers, not even by meters, but by approximately 3.8 centimeters every year, about the speed at which your fingernails grow. It sounds insignificant, a distance so small that no human eye could ever notice it. But the universe possesses something we do not: time. Give 3.8 centimeters millions of years, and the night sky begins to change. The moon is not moving away because it wants to escape. It is being pushed outward by an ancient gravitational exchange, one that happens every day, inside Earth's oceans. The moon's gravity pulls on our planet. It stretches the oceans, creating enormous bulges of water that travel around Earth as tides. But those tidal bulges are not positioned directly beneath the moon. Earth rotates much faster than the moon moves around us, so our spinning planet carries the ocean slightly ahead of the moon's position. That displaced water has gravity of its own, and its gravitational pull gives the moon a tiny forward push. The effect is almost impossibly small. Yet every day, every tide, every movement of the oceans transfers a little of Earth's rotational energy to the moon. The moon gains orbital energy and moves into a slightly wider orbit. Earth, meanwhile, rotates a little more slowly. The moon moves farther away, and our days become longer. It is a cosmic exchange that has continued for billions of years. The moon did not always appear as it does today. Shortly after its formation, it was much closer to Earth, far larger in the sky. Its gravitational influence was stronger. Its tides may have been enormous. And the young Earth rotated much faster than it does now. A day may once have lasted only a fraction of our modern 24 hours. But as the moon slowly traveled outward, Earth's rotation slowed. Days grew longer. The moon became smaller in our sky. And the world gradually transformed into the one we know today. This means that 24 hours is not a permanent feature of Earth. It is only one moment in an evolution lasting billions of years. Far in the future, a day on Earth will become slightly longer. Not suddenly. No one will wake up tomorrow and discover an extra hour. The change is far too slow for an individual lifetime. But over geological time, seconds become minutes. Minutes become hours. Future clocks and calendars would eventually describe a world moving to a different rhythm. Longer days, longer nights, a slower turning Earth beneath a smaller and more distant moon. But one of the greatest changes will happen in the middle of the day. Today, humanity lives during an extraordinary moment in cosmic history. The sun is roughly 400 times wider than the moon, but it is also roughly 400 times farther away. Because of this remarkable coincidence, the sun and moon appear almost exactly the same size in our sky. When their paths align perfectly, the moon can cover the brilliant surface of the sun, while leaving the solar corona glowing around it, a total solar eclipse. For a few minutes, day becomes night. Stars appear, temperatures fall, and animals react as though evening has arrived. And the shadow of the moon races across Earth. But total solar eclipses are temporary. As the moon continues moving away, its apparent size in our sky continues shrinking. Eclipses will slowly become less frequent. The moon will struggle to cover the entire sun. Then, hundreds of millions of years from now, there will come one final total solar eclipse. Observatories may follow the moon's shadow as it crosses the planet. Millions may gather beneath it. Cameras may record every second. The moon will move in front of the sun, the sky will darken, the corona will appear, and for the last time in Earth's history, the sun will be completely hidden. Then the moon will continue along its orbit. Sunlight will return, and totality will never happen again. Every future solar eclipse will be incomplete. The moon will always appear too small, a dark circle, surrounded by a ring of fire. The universe does not announce its final moments. There will be no explosion, no sound, only a shadow crossing Earth for the last time. But what will happen to the tides? The moon is the main driver of Earth's ocean tides. As it moves farther away, its gravitational influence weakens. The moon's tides will gradually weaken. The sun also pulls on Earth's oceans and creates tides of its own. But the familiar rhythm of our coastlines would slowly change. The difference between high and low tide could become smaller. The moon's retreat is therefore not only an astronomical story, it is written into Earth's oceans, its geology, and perhaps even the history of life itself. Fortunately, the moon is not about to disappear. At its present distance, it remains gravitationally bound to Earth. In an extremely distant theoretical future, the exchange could move the Earth-Moon system toward a state in which Earth's rotation and the moon's orbit become synchronized. Earth would rotate once during each lunar orbit. From one side of Earth, the moon would appear almost fixed in the sky. But they probably will not have enough time to reach that peaceful ending, because another clock is already running. The sun is aging. Several billion years from now, the sun will exhaust the hydrogen in its core. It will expand into a red giant. Long before the Earth and moon can complete their slow gravitational dance, the sun may alter their orbits beyond recognition. The moon was born from violence. A massive collision struck the young Earth more than 4 billion years ago. Material was thrown into orbit. That debris gathered together and became the moon. Since then, Earth and moon have evolved as a pair. They are not simply a planet and a satellite. They are survivors of the same ancient catastrophe. Two worlds, still connected by gravity, slowly moving apart. Long after every building standing today has disappeared, the moon will still rise. Smaller than before, farther than before, but still there. Perhaps future civilizations will look at ancient photographs of enormous total eclipses. They may study recordings from an era when the moon could perfectly hide the sun. And they may envy us because we happen to exist during a brief period when the sizes and distances align almost perfectly. Tonight, when you look at the moon, remember, some goodbyes do not happen in a moment. Some take billions of years. Until next time, keep looking up, because every answer reveals another mystery.